Hello, good day to everybody. As in the part of Python programming, today we are going to discuss about operators and expressions in Python. So these are very simple operators and expressions and available in every programming language. Even though these are simple, but these are very important to understand and learn because without operators, it is not possible to express or write a program logic. So for writing program logic, operators and expressions are essential, and this knowledge is very, very important. So uh, don't think that these are very simple. We know like that. Just to follow. See, operators and expressions in Python. We have these many types of operators. That is the today's agenda. Arithmetic operators, comparison or relational operators, assignment operators, logical operators, bitwise operators, membership operators, and identity operators. These membership and identity operators are specific to Python, and these are newly introduced operators in Python. So they have some specific meaning. We will discuss about all these things. So operator, first of all, we need to understand what is an operator. So if you see, operator is a symbol or a construct. You can say that the operator is a symbol or construct which is used to perform an action or which is used to represent an action performed on operands. It is used to represent an action performed on operands. So here you need to understand what is an operand. Operand is nothing but the values provided to the values or variables in expression. Those we can call it as an operand. For example, if you take, here, if you take, see an example is here, 4 plus 5 equal to 9. In that 4 plus 5, plus is an operator. So consider the expression here, 4 plus 5 equal to 9. Here 4 and 5 are called operands. Number 4 and 5 are called operands, and plus is called an operator. So, of course, sometimes these expressions will be like this, sum equal to a plus b. In this a plus b and sum, all these we can call as an operands. All these we can call as operands. Okay, this plus and equal to are operators. These are called operators. That's why we define operator is a symbol or a construct which represent an operation in an expression. It's represent an operation in an expression, or which is used to perform operation or operations on operands. So that is here a plus b, here plus operator plus operator represents the addition or sum of what a and b. Here a and b are the operands. So here a symbol plus is representing that here addition operation is going to be performed. Addition operation is going to be performed on operands a and b. So that is the meaning of operator. Operator is a symbol or a construct which is used to represent an operation on operands. Represents a operation on operands. What are the different types of operations? Addition, based on different types of operations, we have a different types of operators. We will see those things. See the second example. Consider the expression minus 5. Here minus 5 is an expression. 5 is operand and minus is an operator which make 5 as a negative number. Which makes 5 as a negative number. Or sometimes we can also write it like this, minus a. So minus 5 or minus 10 we can make it as a like this. Okay, so 10 is an operand, 5 is minus is an operator. So this minus operator makes 10 magnitude 10 as a negative number. So that is the importance of the operator here. So while writing logic of the program, we need these operators because logic must be written in by using the expressions. So in those expressions, we need operators. by using operators only, we can write the logic. That is the importance of the operators in programming language. So without operators, no logic. Without operators, we cannot implement the logic. Because of that, we need to understand operators and expressions in in any programming language. So operators are the pillars of the program on which the logic is built in a specific programming language. So Python provides a variety of operators. See the operators in Python. There are arithmetic operators which represents the arithmetic operations. For example, addition, subtraction, multiplication, division, modulo division, and floor division. Like that, we have many operators and even exponential operations. So these many types of operations are there in arithmetic operations. And next, comparison, relational operators, comparing two values, whether they are equal or less than or equal or greater than or equal or less than, greater than, not equal, like that, to compare two operands from one to one. And for comparing two operands, we use the comparison or relational operators. And assignment operators, to assign values to variables. To assign values to variables, we use the assignment operators. Logical operators. So logical operators means logical and logical or logical not, like that. Logical operators are there. So logical operators and bitwise operators to perform operations on operands bitwise. So bitwise in the sense converting those values into binary bits. We perform the operations on the binary bits. So later we will see what is the bitwise operators and how to perform the operations on those. So bitwise operators, and next thing, membership operators. These are the special operators in Python. Membership operators and identity operators. Membership operators are used to identify whether the specified quantity or specified item is a member in a particular group of elements, is member or not in a particular group of elements. In such cases, we can use the membership operators to identify whether the given item is a member or not a member in a given list of items. In such a cases, we can use the membership operators. And next thing is identity operators. Whether two these identity operators are very, very useful. Whether the two variables or two quantities representing the same object or not, to identify in such a cases, we use the identity operators. These are the various types of operators available. These are the various types of operators available in Python. Next, we will see about each and every type in detail. The first one is arithmetic operators. In arithmetic operators, we have 1, 2, 3, 4, 5, 6, 7 operators are there. Addition, subtraction, multiplication, division, modulo division, and floor division, and next exponential operator. So these are the various operators available in arithmetic operators. So plus indicates addition. All of you know that very well. Like this we can use. Or so sum equal to a plus b. Like this we can write as an expression, arithmetic expression. Subtraction. So like this we can use, or difference equal to a minus b, like that we can write. And then multiplication, this is the multiplication. So product equal to a into a star b. You need to remember that in computer, almost all in computer languages, star is used to indicate multiplication. So general in mathematics we use the cross symbol, but here in computers, in the area of computers, we use star as a multiplication symbol. So like this we can use. And division. So this is a float division because it gives the floating point value as an output. It is a quotient. So in this, you'll get the quotient. And modulo division. Modulo division gives the remainder. This is the quotient. This is remainder. Floor division. These are the three types of division operators: floor division, modulo division, and floor division. These are the symbols used for the division. Slash, modulo division, percentage, double slash for floor division. The floor division in the sense, if you want only the integer part after dividing a number with another number, in the coefficient, if you want only the integer part, if the coefficient has a some floating values. In that floating values, if you want to only the integer part, so that you can use this floor division. So floor division gives only the integer part from the coefficient. For example, if you take here 20 by 8, generally it gives 2.5, but I want only this integer part 2. In such cases, I can go for floor division. That is the advantage of the floor division. So next, exponential. For example, exponential is my power. So 2 double star 3, if you mention like this is equivalent to 2 cube, which gives the output as a 8. So that is the arithmetic operators which are used for arithmetic operations. So there are around 7 arithmetic operators are there in Python. So first one is addition, second one is subtraction, third one is multiplication, fourth one is division. That is also called a floor division. And fifth one is modulo division. Sixth one is floor division, and seventh one is exponential. These are the symbols: plus for addition, and minus for subtraction, star for multiplication, slash for division. Next, percentage for modulo division, double slash for floor division, and a double star for exponential. Single star for multiplication, double star for exponential value. So power, to mention the power of the 2 cube, for example, 2 power 4, 10 power 5, like that. If you want to mention anything, we will go for exponential. Okay, so these are the various arithmetic operators, and we will see some of the examples here. So I'm taking two variables x and y. So I have given values for x equal to 15 and y equal to 4. Now we will see the output: x plus 5 equal to 19, x plus y equal to 19, because 15 plus 4 equal to 19. We know that. We are printing here x plus 5 like this. See, 19, x minus 5, 11, and x star y. Here star, I already told, star means multiplication. Okay, in computer languages, star means while doing arithmetic operations or any mathematical operations, we use the star to represent the multiplication. And x by y, 3, here in this case of x by y is 3 point, here observe x by y equal to 3.5. So with the fractions, it's giving. So 3.5 is nothing but the quotient. 15 by 4, 4 3s and 75, 3.75 is the result. Next, x double slash y, x double slash y. What we told that x double slash y, in the coefficient it returns only the integer part. The coefficient is 3.75, but it returns only 3. Okay, that is the advantage. Like that, we can, if you want only integer part from the coefficient, we can take by using the floor division. And x double star y, x double star y, how x double star y, we can represent it as a x power y, x power y. So what is the value of x? 15. What is the y value of 4? And 15 power 4, which is an equivalent to 50,625. X power 4 equal to 50,000. So x power y, which is x power y, where x equal to 15, y equal to 4. So 15 power 4 equivalent to 50,625. Okay, this is the value. Similarly, x star y equal to 60 and x by y 3.75. We have seen this one. Various outputs here and here. Okay, these are the various outputs of arithmetic operators. Next, comparison or relational operators. If you see the comparison or relational operators, here also 7 are there. So these are used to compare two values or two operands, whether they are equal to each other or which one is less than or greater than. Like that, we can check various. We can perform various comparison operations. So here are the symbols used in the comparison operations: less than, greater than, double equal to, not equal to, less than or equal to, greater than or equal to, and not equal to. This is this not equal to was available in older versions. So in Python 3.0, in Python 3.1, so it was deprecated. So this greater than, less than, is less than, greater than symbol, whatever is there, that is also represents the not equal to. So it was there in initial versions. At present version, this operator was deprecated. It is not available. So these are available at the present. Okay, for not equal to, nowadays we are using this one. Not symbol and equal to, we are using this one. Okay. So syntax, how we can write, this is the syntax of comparison operators. 5 less than 10. Yeah. Suppose not only numbers, we can also use the variables x less than y. Like this, we can use x less than y or x greater than y. So like this. If suppose, for example, x is less than y, then it represents it true. In this case, we'll see some of the examples. Here you see x equal to 10, y equal to 12, x equal to 10 and y equal to 12. So x greater than y. So x 10, y 12. So 10 is, if you replace this expression with values, 10 is greater than 12. Is it true or false? False. So it returns false. These comparison operators return either true or false based on the condition. Either true or false based on the expression. Values in the expression. In this case, x value is 10, y value is 12. In this case, if you write like this, x greater than y. Okay, x greater than y. 10 greater than y. So 10 greater than 12. So 10 is not greater than 12. Because of that, this expression becomes false. This expression becomes false. We'll see next. Print x greater than y is x greater than y. So what it is printing? X greater than y is false. Okay, because this expression prints gives false as an output, because 10 is not greater than y. 10 is less than y. So whenever you are using x greater than y expression for this x and y values, it is returning false. So this is false. And next, x less than y is true because 10 is less than 12. For this x and y values, 10 and 12, x is less than 10, 10 is less than 12. So it is satisfied the condition. That's what it's given. It gives a true as an output. In another case, x equal to y, this is also false. So this double equal to symbol is used to check the equality of the operands. If both are equal, then it returns true. Otherwise, it returns false. And in this case, it returns false because both are not equal. And next one is output x not equal to y. Is the symbol not equal to explanatory and equal to not equal to x not equal to y, because 10 and 12 both are not equal. So it returns true. It returns true. So like the next, x greater than or equal to y. So this condition here, greater than or equal to, what it represent? The left side quantity. If the left side quantity is greater than or equal to the y, the operand of the right side of the operator, then it returns true. Otherwise, it returns false. For example, if you take here x equal to 10 and y equal to 12. So 10, replace the with values. 10 is greater than or equal to 12. No, it is not greater than or equal to 12, which is the less than. Which is the less than 12. 10 is the less than 12. So it returns false. Suppose here, if you have a 12 like this, 12 is greater than or equal to 12 means, so here, any one of the condition, if even any one of the conditions satisfied, the entire expression will be satisfied here. So in this case, x greater than or equal to y. Two conditions are there, greater than and equal to. This expression satisfies when x value is equal to y or x value is greater than y. So there are two comparisons in this expression. There are two comparisons. We will see now clearly. When it is true. For example, x greater than or equal to y. For example, x equal to 10, y equal to 12. In this case, 10 is greater than or equal to 12, which is absolutely wrong. So it returns false. Okay, it returns false. For example, now we will change the x and y values. X value is 12, y value is also 12. Now, okay, now 12 is greater than or equal to 12. Okay, so 12 is, now this will be treated as like this: 12 greater than 12, or 12 equal to 12. So like this can be converted. So any one of the expression becomes true, then entire expression becomes true. Here 12 is equal to 12, so this expression becomes true and it returns true. Okay, in another case we will see. For example, x is 30. In this case we can write like this. In this case we can write like this: 13 is greater than or equal to 12. Yeah, 13 is greater than 12. First condition is satisfied, as 13 is greater than. So this condition true and it returns true. Like that, x greater than or equal to y works. Similarly, next one is x less than or equal to y. In this case also, there are two conditions: less than and equal. So if x value is less than y, then it is true, and or x value is equal to y, then it is true. In the two cases, this expression becomes true and it returns true. Otherwise, this expression becomes false and it returns false. So that is the comparison or relational operators. Explanation with example. See here, x greater than y is false because 10 is not greater than 12. X less than y is true because 10 is less than 12. You know that. X equal to y is false because 10 never equals to 12. And x not equal to y is true because 10 and 12 both are different magnitude values. So they never equal to each other. They are not equal. So it returns true. X greater than or equal to y is false because x is neither greater than nor equal to the y. So this returns false. Next, x less than or equal to y. In this case, x is less than 10. Of course, not equal to y, but less than 10. Any one is satisfied, then expression becomes true. That is how comparison and relational operators works. Next thing is assignment operators. So there are assignment operators means to assign values to the variables we use. So in an expression, if you take an expression, so in multi-value, in this expression, suppose for example, if you take x equal to a, like that, if you take an expression. So here it is a left hand side quantity, and this is the right hand side item. So it means right hand side variable, whatever it is there, or right hand side value, whatever it is there, that is assigned to the left hand side variable or a left hand side quantity. So x equal to a, in the sense we are assigning value of a to x. We are assigning value of a to x. For example, x equal to 5. Now we assigned 5 value to variable x. That is the meaning of assignment. Assignment is nothing but, so it assigns the value right side to the variable. It assigns the value to the x. That is the assignment operators. In simple assign, x equal to 5, x equal to a. These are the simple assignments like this. For example, s equal to 5. If we take like this, simple assignment operator. So we are assigning value 5 to s. It's very simple assignment operator. So there are some other assignment operators. For example, like this: plus equal to, minus equal to, star equal to, slash equal to. Like this, there are some like this. Many operators are there. This is here is the list with arithmetic operations and logical operations. We have many of the assignment operators. These are also called shorthand operators. is also called shorthand operators. Shorthand operators. So what does that mean? Plus equal to, minus equal to, star equal to, all these things. Here, see, x plus equal to 5. It means x equal to x plus 5. Okay, x equal to x plus 5. For example, x minus equal to 5. It means x equal to x minus 5. So x star equal to 5. It means x equal to x star 5. You can ask me, already we have expressions like this to express x plus 5, x minus 5, and x star 5, all those things. Then why we need the shorthand operators? Plus equal to, minus equal to. Every operator is like that. Yeah, there is an important and performance oriented reason for this. So to improve the performance while representing such a type of expressions, we use the shorthand operators. X plus equal to 5. See, with the example, I will explain you the reason. If there is no shorthand operators, what happened? If you use the shorthand operators or the assignment operators, what happens? For example, in this case of x equal to x plus 5. So while executing this program, first it has to identify the variable x in the memory and access the value of that x, and has to add this value to that x. Okay, for example, in memory, this is the location x. In this x, we have already value 10. First, while executing this x has to be identified in the memory, and then again, this value has to be read. This 5 has to be added to this 10, 15. Okay, and when this part is over, okay, and again here equal to is there. Whenever it identifies an equal to operator, it means it is an assignment operator. Whatever the value is here available, that value has to be assigned to the left side variable. So now again it starts searching for x, but it's already value changed to 15, and the same 15 it is assigning second time to the x. So 15 again overridden. So 15 is there. Now again the 15 is overridden. What happened in the memory? So the same operation it is doing two times. Unnecessary operation it is performing. So time waste because of this unnecessary operation. What is happening? The execution time will increase. So two times it is doing the same operations unnecessarily. So to avoid such things, while writing these expressions, we'll go x plus equal to 5. We'll write like this. What happened now? Now this is the x in the memory. First 5 is there, so there is no any expression. The only value is there. Now it looks for operator plus equal to is there. What is the quantity to the left side? X. First it try to access the x in the memory. So what is there in the x? 10 is there. For that, it adds 5 plus 5. So now it becomes 15. Now it becomes 15. Operation is over. So no need to again access the x here. That is the advantage of the shorthand operators. In every case, it's similar in all the cases. It's same, similarly plus equal to, similarly minus equal to, similarly star equal to, similarly slash equal to. Every operation will happen like that. Mod slash equal to, double slash equal to, star equal, everything like that. So we are avoiding unnecessary access here. So that is the advantage of these shorthand operators. Okay, like that we can write many operators are there. Next we will see logical operators. In logical operator, to perform the logical operations among two operands, we use the logical operators and are not are the logical operators. So we know that logical operators. So when we're dealing with, for example, so we know the logic gates in electronics subject. Logic gates are there: AND gate, OR gate, so NOT gate, like that we know. So for those we have some truth tables also, and gate, OR gate, and NOT gate. So to perform such a type of logical operators, we use these logical operators and or not. Okay. So suppose, for example, if you write like this, x and y, this is an expression, x and y. So these logical operators returns either true or false. So output from the logical expression is either true or false. What is the output from logical expression? Output from the logical expression is either true or false. It may be true or false. If expression becomes true, then output from that expression is true. If expressions becomes false, then it returns false. When this expression becomes true and when this expression becomes false, we need to identify. There are some rules and regulations to identify those things. For example, in this case, and for and, you can write the truth table like this. For example, two quantities and then output. If both the quantities are true, then it becomes true. In remaining all cases, I will write clearly. Otherwise, you remember like this. Two operands, for example, A and B, and the result. If A equal to true, B equal to true, logical operators, operator and. So when it becomes and when it becomes true and when it becomes false. If you see, there is a truth table for this like this. This is the operand 1, OP1, this is operand 2, and this is the result. So true, then it becomes true. True, false, then it becomes false. False, true, then it becomes false. False, false, then it becomes false. So for two operands, these are the possible combinations. Maybe both are true, or one true and another false, or first one is false and another one is true, and both are false. These are the possibilities for two operands. For these possibilities, if both the quantities are true, then output becomes true. In all other cases, output becomes false. Blindly remember it. So in logical, while doing the logical operators, if both the operands are true, then output becomes true. Otherwise, output becomes false. So that is the rule for logical AND. And next one is logical OR. If you see the logical OR, for logical OR, similarly, if you take two operands, any one of the true, then output becomes true. Otherwise, output becomes false. So anyone. So in this case, or if you take or P1, P2, and then result true, true. What we say, if anyone becomes true, then output becomes true. So both are true, no problem. It is true. True and false. One is true, another one is false. So it is true. False and true. Yes, one is false and another one is true. This is true. False, false. No one is true here. So it becomes false. Okay. If you take AND, if both are true, then then the expressions become true. In our case, if both are false, then expression becomes false, and otherwise it is true. Okay, that is the thing. Not means if, I will explain. Not if operand is true, then after applying the not, it becomes false. If operand is false, after applying the operand, it becomes true. It means complement. For example, if you take a P1, if it is 0, result is 1. If it is 1, result is 0. So complement operation. It performs the complement operation. It is called the complement operation. So this is how logical operators works. See here the examples. Sorry, here only. X and Y. Here we have given x equal to true, y equal to false. Print x and y is x and y. Like this we can write the expression. So this returns false because x is true, y is false. When and expression becomes true, both the quantities are true, then entire expression becomes true. But here x is true and y is false. X is true and y is false. Because of that, x and y becomes false. Next one, x or y. So any one true, then entire expression becomes true. That's why x or y becomes true. It returns true. Output is true here. And next one, not x. X equal to true. Here we are printing not x. Not x means it becomes false. If you print not y, it becomes true. So because y is false. So like that, these logical operators works. And next, if you see the bitwise operators, next one. Bitwise operators means if you want to perform addition or subtraction, multiplication, so, or any, if you want to perform operations bitwise in the sense, for example, in binary format, if you want to perform operations in binary format, so in such a cases, we use the bitwise operator. For example, here they have given 2, 10, two values, x equal to 2 and y equal to x equal to 2 and y equal to 4. These are the decimal values. So in numbering system, we have a binary numbering system also. In binary numbering system, 2 is equal to 10 in binary, 4 is equal to 100 in binary. This is in decimal, this is in decimal, this is in binary. Okay, this is how we can represent in binary. So if you want to perform any operations in binary format, we go with the bitwise operators. These are the operators we have. And, binary or, binary, that's bitwise not, next bitwise XOR, and bitwise shift, bitwise right shift, bitwise left shift. These are the values we are having. Bitwise AND, bitwise OR, bitwise NOT, bitwise XOR, so bitwise right shift, bitwise left shift. These are the various operators we have. Now we will see example with example. X and Y. If you perform X and Y, what happened? X equal to 10 in binary, Y equal to 100. But while performing these operations, computer take 8 bits for this. So 0, 0, 0, 0 and 0, 0, 1, 0. Next thing is 0, 0, 0, 0, 0, 1, 0, 0. Okay, 8 bits of 2, 8 bits of 4. Okay, now X and Y, it becomes 0, 1, 0, 0, 0, 1, 0, 0, all it becomes 0. 0 in binary. X and Y becomes 0 in binary, but we have to represent in 8 bits, like that. Okay, and next operation we will see. X or Y. Like this we can represent. Okay. 0, 0, 0, 0, 0, 0. Here in this example, 0, 0, 1, 0. So we take an x equal to 2, y equal to 4. For this I am taking 0, 0, 0, 0, 0, 1, 0, 0, 4 or 4. Okay. Now x or y. While performing x or y, you have to see to the digits from each and every number. 0, 0, 0 or 0 becomes 0. 1 or 0. If any one of the input is 1, then output is 1. So any one of the input is 1, then output is 1. But here both are 0, 0, remaining all zeros. So 1, 1, 0. This is the output for x or y. Okay. And next, we'll see another example, another operator. So not symbol is applied to only single operand. It is not applied to two operands. So here not x, like this, not x. So x value, we take x as a cube in decimal. If you convert it as in binary, this is like this, x in binary. So not x in the sense zeros becomes ones and ones becomes 0. Like this we can represent. Okay. This is the complement value. You can say that this one has a complement. That is the bitwise not. Okay. And next thing, XOR, exclusive OR. This is another operator, exclusive OR. We have seen AND OR not operations. In the case of XOR, this is the symbol. This is the symbol. So X XOR Y, bitwise operator. Like for example, X equal to 2, Y equal to 4. X value is 0, 0, 0, 0, 0, 0, 1, 0 in binary. Y equal to 0, 0, 0, 0, 0, 1, 0, 0 in binary. So now x or y, how we can take like this? You make arrangement in this manner. See the input. If there are odd number of ones in the input, then it becomes 1. Otherwise 0. Okay. So 0, 0. There are no inputs. There are no ones. So it becomes 0. 1, 0. How many ones are there? Odd number of ones are there. It becomes 1. 0, 1. How many ones are there? Odd number of ones. It becomes 1. 0, 0. Remaining all 0. This is how the output will come. Okay. So in the case of XOR, if odd number of inputs are there, then output becomes 1. Otherwise, output becomes 0. That is the logic. So in case of logical AND, in case of bitwise AND, if both the values, both the operands are 1, then only it becomes 1, otherwise it is 0. In our case, any one of the input is 1, output becomes 1. So those are the examples. Next, bitwise right shift. Right shift, if you take right shift, you will take x equal to 10, then we will see. Then you will understand. 2 times I am shifting to right. Actually 10 is 0, 0, 0, 0, 1, 0, 1, 0, 1, 0. This is the 10, binary 10. This is the decimal 10. Okay. Here you observe, you can understand very easily here. In the previous example, I took 2, so there may be confusion in that for you. Now I take 2 only, 10. With the 10, I will explain. This is the binary 10. So what is the meaning of this expression? You have to shift 2 bits to right side. 2 bits to right side means you have to shift in this direction 2 bits. So when you shift 2 bits, you have to push zeros from left side. You have to push zeros from left side. I'll show you now. Take like this: 1, 2, 3, 4, 5, 6, 7. Assume like this: 0, 0, 0, 0, 1, 0, 1, 0. Now you have shifted 1 bit, so this 0 comes out. Here you have pushed 0 from here. Now what happened? Now this value becomes 0, 0, 0, 0, 0, 0, 1, 0, 1. It becomes like this. Okay. Now again, one more shift, two shifts, right? One more shift like this. Now it becomes 0, 0, 0, 0, 0, 0, 0, 1, 1, 0. It becomes like this. 1, 0, 1, 0. Okay. Otherwise, it means it becomes 2. Okay. 1, 0, 1, 0. You have to shift 2 times right side. During the first shift, it becomes 0, 0, 0, 0, 0, 1, 0, 1. So one bit like this and add 0. And during the second shift, again you have to move from this side to like this 0, 0, 0, 0, 0, 1, 0. So it becomes 2 now. Okay, like this you can perform the shift operation. So every time you shift one bit right side, the number divides by 2. So in this case, take 10. First time it becomes 5, and second time again it becomes what? 2. Actually 2.5. It takes integer part of it becomes 2. So like that, in decimal 2.5, but in binary operations you will get 2 only, even though it is 2.5. So 10 by 2, 5, again by 2, it becomes 2 now. Okay, like that. If you shift left side, it multiplies 10 into 2 for 1 time 20, 2 times, again it becomes 40, 10 becomes 40. Now we will see it, left shift. It means you have to shift left side. The same, x equal to 10, 0, 0, 0, 0, 1, 0, 1, 0. Now left shift. So move this side. Move with 0. What happened at 0, 0, 1, 0? Okay? 0, 0. One more 0 added here. Left shift. What happened first time? It becomes 0, 0, 1, 0, 1, 0, 0, 0 in first shift. And again in second shift, 0, 0, 0, 1, 0, 1, 0, 0. So it is equivalent to 40. You can calculate it like this, 2 powers, 2 power 0, 2 power 1, like that you can calculate it, and it becomes 40. So every time, every shift to left side multiplies with by 2, multiplies by 2. Every shift to right side divide by 2. That is the operation. And next, membership operators. In and not in. These two are the membership operators. So if you take operator in, it returns true if value or variable is found in the sequence. So especially these are applied to the sequence types. So in the sequence, if the value, whatever the value you have taken, that value is there, it returns true. If it is not there, it returns false. The operator not in also do the same thing. True if value or variable is not found. Okay, if value or variable is not found in the sequence, then not in operator returns true, otherwise it returns false. This is the examples here. See the example. 5 in x, 5 not in x. If 5 is not there in sequence x, then it returns true, otherwise it returns false. If 5 is there in sequence x, then it returns true, otherwise it returns false. It is the some examples, membership operators examples. X equal to hello world. This is the string. String is a sequence type, and y equal to it is the 1a 2b. 1 is a key and a is a value. 2 is a key and b is a value. Like that, we have two sequences x comma y, x and y. So these sequence operators are, you can say that, case sensitive operators. So capital H is not equal to small h. You need to remember that capital letters or small letters, both are treated as a different characters. Okay, even the same characters, they're treated as a different characters based on the case. Capital H and a small h both are different in this case. The capital H in X, in X H is there. Because of that, it returns true. Okay, because operator we use is in. So hello not in X. Hello small h. Hello starts with a small h. So not in X. It returns true. Not in. If it is not there, then it is still. It becomes true. We are using a not in. In X, what is there? Capital hello is there. Hello starts with a capital H, but here hello starts with small h. So this hello is not there in X. That's why it is written true. Next, 1 in Y. So 1 is the key value. Key value is there in Y. That's why it returns true. A in Y, it returns false. Okay, A in Y, it returns false. So A is a value of the key 1. Because of that, it returns false here. So only it reads as 1 to key values as the values of Y, and it returns false in that case. Okay. Next, identity operators. Is and is not. Is and is not are the identity operators in Python. They are used to check if two values or variables are located on the same part of the memory. Two variables that are equal does not imply that they are identical. Okay. What does that mean? X is true, X is not true. Means, the example I will show you. X1 equal to 5, Y1 equal to 5, X2 equal to hello, Y2 equal to hello, X3 equol to, we will take a tuple like Y3 equal to like that. You print X1 is not Y1 false. Why it prints X1 is not Y1? So both are, it means both are representing the same object in the memory. So X1 and Y1 both are representing the object 5 in the memory. Here we are using is not, that's why it is printing false. If you use is X1 is Y1, then it returns true. Okay, X2 is Y2, so it returns true because X2 and Y2 both are representing the same object in the memory, that is hello. So here another example, X3 is Y3. For you need to understand, in this case 1 2 3 1 2 3 both seems to be same values, but they may be different memory locations in the memory. That's why X3 and Y3 returns false. X3 is Y3 returns false. Like that it works. Okay. Operators precedence. How precedence and associativity of operators affect the order of the operations in Python, we will see now. So operators and operators precedence, when it is required and why it is required. Precedence, it means an order, in which order an expression has to be executed. Generally, if you take, expression may contain many number of operations and operators. If there are many number of operators in an expression, in which order they have to be evaluated to get the proper output. So this operator precedence decides that one. Okay, see here, this is the order. The highest order is for parenthesis, and next exponent, and the next is unary operators, unary plus, unary minus, unary bitwise operators, all those things, plus x minus x, unary x. So why this is the order we need to follow. They have already mentioned in a tabular format. This order has to be followed while evaluating the expressions manually. Even computer follows this order. Because of that, while calculating anything manually, we need to follow this order. Okay, and next, multiplication, division, floor division, modular division operators, and then addition and subtraction. After that, bitwise shift operators, and then bitwise and bitwise XOR, and logical OR, and next bitwise OR, and then assignment operators, comparison, identity, membership operators. All these things comes into the, and next logical NOT and logical AND. This is the hierarchy. This is the priorities. So starting from highest priority, parenthesis having highest priority, like that priority is reducing step by step to the end. Okay, in this order, this priorities or this operator precedence will be defined. Based on the precedence, that expression will be executed. In some cases, even in the single expression, so if you see in this table, we will find at this category there are 1, 2, 3. 3 are there: unary plus, unary minus, and bitwise not. At this row, we can find 4 operators: multiplication, division, floor division, modular division. In this case, plus minus, we have 2 operators. Here we have 2 operators like this. So at same priority, many operators are there. In such a situations, we will consider associativity. Okay, precedence is order, in which operation has to be executed first and which operation has to be executed next, like that. To decide the priority of the operations, we take precedence. In case if there are more number of operators at the same level, so at the same priority level, in such cases, which operation has to be taking forward first, in which direction this operation has to be carried forward, associativity will decide. Associativity will decide. Always associativity is left associativity or right side associativity, like that. Left to right or right to left associativity will be there. Two types of associativities: left to right and right to left associativities will be there. Now we will see this. Here see 5 star 2 slash 3. This is the expression we have given like here. Okay. This is the left to right associativity is following here, because you see star, it means multiplication, division, floor division, and modular division. These are all having same priority. When in an expression, there are the operators with the same priority. So what is the associativity we need to follow? In this case, left to right associativity we have to follow. It means now first operation 2 double slash. Now first operation is 5 star 2 will happen left to right. Left side nunchi, from left side we have to start. 5 star 2 10, 10 by 3, like that. Left to right we have to carry the operation. Okay, 9.3 something will come, 10 by 3 in the sense. So output is 3 here. Okay, next step shows left to right associativity. Again output is 0. 5 star 2, okay, 2 double slash 3. Here they have given in parenthesis. So parenthesis is having always highest priority. So first it happens 2 mod 3. 2 mod 3 in the sense it becomes 0, not mod. 2 floor division 3. So 0 point something will occur. Because of it's a floor division, it considers only the integer part. Integer part is 0. 5 into 0 is 0. So output becomes 0 here in this case. Okay. And next shows the right to left associativity. Double star here. Output 5. Since 2 star star 3 star star 2, it is like that. There are 2 operations we are performing here. So 2 star star in parenthesis 3 star star 2 is there. So here parenthesis mentioned. So no issue. First, whatever the operation is there in parenthesis, because it is having highest priority, first this will be performed. 3 square, it becomes 9, and it becomes total, it becomes 2 power 9, like that. Suppose if you write the same expression like this, 2 star star 3 star star 2, then what happened? Right to left associated. First it happens, and then it will be taken into consideration. So 3 square is 9. First it is calculated, and then 2 power 9 will be calculated. Okay. If 2 needs to be exponential first, if you want to 2 power 3 has to be happen first, and you have to make the parenthesis for this 2 power 3, like this. Okay. And next we'll go to the expressions. So we have seen we cannot divide expressions and operators separately. So all these are expressions only. Whatever explained we are here, expressions. So for your clarity, So these are all expressions we can say. These are all expressions. X2 is Y2, X1 is not Y1. Okay, XC. Okay, these are all expressions only. Without expressions, we cannot write operators. We cannot explain the operators. So already expressions are also explained here, but segregating here expressions. These are the different type of expressions we can write. Constant expressions, arithmetic expressions, integral expressions, floating point expressions, relational expression, logical expressions, bitwise expressions, combinational expressions. So constant expressions it means in that expressions constant values will be there. 15 plus 1.3 is the constant expression. The output will be 16.3 like this. Only constants will be there in the expressions. So such type of expressions are constant expressions. And the arithmetic expressions. So the expressions which represents arithmetic operations, those are called the arithmetic expressions. And integral expressions, so which operates only on integers, which operates only on these expressions contains only integer operands. Such a type of expressions are called integral expressions. Floating point expressions. The result of this expression will become a floating point. Then such type of expressions will become a floating point expressions. Floating point numbers as a result. Here, integers as a result. Okay, and relational expressions. So this produces the result either true or false like that. If this type of expressions, arithmetic expressions are written on both sides of relational operators by using greater than, less than, greater than, or equal to, less than, or equal to like that. These expressions produces the output either true or false like that. See here, A equal to 21, B equal to 13, C equal to 40, D equal to 37. B equal to A plus B greater than or equal to C minus D like that. We can write the expressions with relational operators. These returns either true or false based on the condition. Okay. Such type of expressions are called relational expressions and logical expressions. These are also written either true or false, but these use logical and logical or and not operators like this P and Q, P or Q, not P like that. So these are the logical expressions, bitwise expressions and combinational expressions. Bitwise expressions means so bitwise. These are the kind of expressions in which computations are performed bit level. A double greater than 2, A double less than 1. This is the shift, bitwise shift and bitwise shift operators, bitwise right shift and bitwise left shift operators. These are like such type of expressions are called bitwise expressions and combinational expressions. Sometimes we may have a different combinations of expressions. Here, A plus B right shift 1 is there. It means B has to be shifted 1 bit right side and then the result will be added to the A. Addition is there. Addition of it means arithmetic expressions are there and bitwise expressions are there here. So combination of the expressions is also possible. Okay. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.